Today's lecture continues with standard normal probability distribution. Let us take an explanatory problem. In a test on electric bulb, all of you take down please. In a test on electric bulb, it was found that the lifetime of a particular brand was distributed normally with an average life of 2000 hours. Note the point, normally. It is not standard normal distribution. So therefore, in an ordinary normal distribution, it is given that the average life of a bulb is 2000 hours. So therefore, I write this as mu is equal to 2000 hours. Also, the standard deviation is given to be 60 hours. 60 hours. What is the meaning of that? The meaning is that if I take a bulb, definitely it gives a life of 2000 hours, or at the best what may happen is 2000 plus 60 hours or 2000 minus 60 hours it will burn. That is what it is telling. So this is a normal probability distribution because he has given it clearly. In a test on electric bulb, it was found that the lifetime of a particular brand was distributed normally. Note the point, normally, with an average life of 2000 hours and standard deviation 60 hours. If a firm purchases 2500 bulbs, they are purchasing 2500 bulbs, find the number of bulbs that are likely to last for, number one, more than 2100 hours. Number two, less than 1950 hours. Number three, between 1900 hours and 2100 hours. So first, we have to note the important point that the given distribution is a normal distribution. Therefore, I have to convert this into standard normal distribution. What is the formula for standard normal distribution? Z is equal to x minus mu by standard deviation. What is mu? Mu is given to be 2000 hours. Let us substitute. Z is equal to x minus 2000 divided by standard deviation, that is 60 hours. So what I did, Z is equal to x minus mu by standard deviation. I have given the formula here. Reason is, this is an ordinary normal distribution. I have to convert it into standard normal distribution using the formula Z is equal to x minus mu by standard deviation. Now here it is already given, mu is given to be 2000 hours, right? Standard deviation is given to be 60 hours. Now the question is, what is the probability that it will bulb more than 2100 hours? Now let us understand what is the value of Z when x is equal to 2100 hours. So that means in this formula, that is in this equation 1, if let us substitute x is equal to 2100 hours. Then what happens? Z is equal to, when I keep x is equal to 2100, this becomes Z is equal to 2100 minus 2000 divided by 60. So therefore, this will become 2100 minus 2000, that is 100. 100 by 60. 100 by 60 is 1.67. So what has happened? When x is 2100, when the normal variable is 2100, the standard normal variable is given to be 1.67. So problem number 1, it is converted as, in the standard normal distribution, what is the probability that z is greater than 1.67? So I rewrite problem number 1 like this: probability of, as this is a normal variable, I use x, probability of x greater than 2100. This gets converted to probability of x gets converted to z by this formula, z greater than, what is the value of z? 1.67. Again, I will explain. Observe, given is an ordinary normal variable. So therefore use the substitution, z is equal to x minus mu by standard deviation. X minus mu is given to be 2000. Standard deviation it is given to be 60. Now what is the question? More than 2100 hours. That means when x is 2100, keep x is equal to, here substitute x is equal to 2100, then what is the value of z you calculate. What is the value of z you are getting? 1.67. So therefore the problem statement, probability of more than 2100 hours, this refers to x. This refers to x. So therefore I write probability of x greater than 2100. This x gets converted to z. What is the value of z? 1.67. So therefore, now how to find probability of z greater than 1.67? You know it already. Whenever there is a greater than sign, what you are doing? This is nothing but, observe here, if I take this curve, suppose this value is z is equal to 1.67, I have to find this area. Whenever greater than this comes, I have already told you, you have to subtract it from 0.5 minus a of this number 1.67. I repeat, observe, probability of x is probability of x greater than 2100 is becoming probability of z greater than 1.67. I have already told you, whenever probability of z greater than comes, you are subtracting from the total right hand side area. What is the total right hand side area? It is nothing but this 0.5. This total right hand side area is 0.5 minus area corresponding to z is equal to 1.67. So if you look at what is the area corresponding to 1.67, that means you go to z column, observe where is 1.67 against z. Against z, you go to z column, find the point z is equal to 1.67. You see what is the area of AZ. If you search that, it is given to be 0.4525. So when z is 1.67, in the standard normal distribution table, you will find when z is 1.67, area is 0.4525. So I am substituting here 0.5 minus a of 1.67, that is 0.4525. So this is the value of the probability, that is probability of z greater than 1.67, and that value is 0.0475. Now, how many such bulbs are there means he has purchased 2500 bulbs. So therefore, multiply this probability by 2500 bulbs. So that is number of bulbs giving durability of more than 2100 hours is equal to this probability 0.0475 into 2500. So that will become 119. Now let us go for the next problem. What is the next problem? Less than 1950 hours. So again I am taking the substitution. Z is equal to x minus mu by standard deviation. X minus, what is mu? Mu is already given. What is that? Mu is 2000. I am substituting 2000 divided by standard deviation. It is given to be 60. Now what is the second problem I am talking? Less than 1950 hours. X is referring to 1950. So therefore substitute x is equal to 1950. Then what happens? 1950 minus 2000 divided by 60. So this value is minus 0.83. So now let us write the statement of problem number 2. What is problem number 2? Less than 1950 hours. Which one is less? X is less than 1950 hours. That is probability of the normal variable x less than 1950 hours. It is equal to this x gets converted to z. Z less than minus 0.83. What does it mean? It means like that. Observe. This is the point says z is equal to minus 0.83. Less than means this area I have to find. So whenever it is on the left hand side, what I am trying to do, I am trying to cut the I cut this portion and I am pasting this to right hand side, that is this into marked area, right? If I cut this portion and fix it here, automatically it will come and sit here. So what is that? Z 0.83. So remember, in a very simple way, minus becomes plus. Probability of z greater than or equal to 0.83, right? So this area I have to find. So once again, whenever greater than or equal to sign comes, what I am doing, right hand side says area, say this area is A, B, C, D. Total area A, B, C, D. Total area is 0.5 minus this area corresponding to the shaded portion 0.83. Or in a more simple way I tell you, when z is less than or equal to a negative number, this less than or equal to becomes greater than or equal to, this minus becomes plus. So whenever there is a greater than or equal to sign, then what I am doing, I am subtracting from 0.5 minus area corresponding to this number 0.83. So 0.5 minus area corresponding to the number 0.83 is 0.2967. I mean, if you go and search in the Z table, when Z is 0.83, you will get area of Z to be 0.2967. So this is the probability. Now, what does it mean? Probability of Z greater than or equal to 0.83 is this value, 0.5 minus 0.2967, that is 0.2033. So what does it mean? It means probability of the bulb giving the durability less than 1950 hours is equal to 0.2033. But how many such bulbs are there? Since in the stock there are 2500 bulbs, the number of bulbs, so I am writing the probable number of bulbs giving the durability less than 1950 hours is equal to number of bulbs. How many bulbs he has purchased? 2500 into 0.2033, right? So similarly, let us go to the next problem. What is that next problem? He has asked, what I asked is, what is the probability that the bulb gives the durability from 1900 hours to 2100 hours? So therefore what you are doing, again you are taking the substitution, z is equal to x minus mu by standard deviation, that is x minus 2000 by 60. Now when x is 1900, see what is the value of z. When x is 2100, see what is the value of z. If I calculate that z value is minus 1.67 here, this one is plus 1.67. So therefore probability of x greater than 1900 less than 2100 So as I have used the substitution, this x gets converted to z, right? This x gets converted to z. So when x is 1900, z value is minus 1.67. When x is 2100, z value is plus 1.67. Now I had to find the area under the curve between the ordinates. Z is equal to minus 1.67, z is equal to plus 1.67. So that means this area as well as this into marked area. What is this ordinate? Z is equal to 0. So from z is equal to 0 to z is equal to 1.67. So I can split like this, probability of minus 1.67 it starts up to z is equal to 0, that is 1 point. So probability of minus 1.67 less than or equal to z less than or equal to 0, that is 1. Another one is probability of this into marked area, that is starting from z is equal to 0, z greater than or equal to 0, less than or equal to up to z is equal to 1.67. So therefore, as I have already told you, if I convert this to right hand side, this becomes probability of 0 less than or equal to z less than or equal to this minus becomes plus 1.67. This one is again same as it is, probability of 0 less than or equal to z less than or equal to 1.67. So therefore, what is this? A of 1.67 minus A of 0. I repeat, A of upper limit 1.67 minus A of 0 plus, here also same thing, 0 less than or equal to z less than or equal to 1.67, A of 1.67 minus A of 0. You are getting, substitute the values, you are getting the probability value. Next, multiply by the number of bulbs you have purchased. How much you have purchased? 2500. When you multiply it by 2500, that gives you the number of bulbs giving the durability from 1900 hours up to 2100 hours. Okay, in the next class we shall continue, right?